Hello viewers, how are you all? Hope you are doing well. So today I have come with another interesting new video of our 3-dimensional geometry lecture series, lecture number 29. So today we are going to find the angle between two planes. So as usual, first we will understand the whole outline of the theory with the real life mathematical models. So without wasting any time, let's start with models first. So today we are going to find the angle between two planes. So angle between two planes are nothing but the angle between the normals to the respective planes. But great Vivekananda once said, don't believe what you hear, but believe on those things only what you can see with your naked eye. So as usual, today we are using a nice mathematical model to understand the whole concept behind this theory. So today we are going to use al posto. See, this is aloo, this is posto. If we mix them, then it becomes the famous and delicious Bengali dish al posto. So jokes apart, today we are considering these two as two planes and these two things as the respective normals to the planes. So this one plane, say pi 1, this one is the normal to the plane, say n1 vector. Here we are using the concept of equation of a plane in normal form, that is r vector dot n cap equal to d. What we have discussed in our previous lecture, lecture number 20 in our 3-dimensional geometry lecture series. You can get all the lectures in my YouTube channel Ssdcapsules. Please go through the lectures and come here, then you can understand all the concepts very easily. Go through the playlist section, you can see the thumbnail with models. Now here I have put these two planes in this manner so that this makes angle between them. So today our objective is to find the angle between these two planes. But here when we keep these two things like that, we get two angles. One is here, this angle, say theta. Another angle is this much angle. There is 180 degree minus theta. That is, it is obtuse angle and this is acute angle. Our objective is to find the acute angle today. So our claim is that this much angle theta, that is the angle between these two planes, and nothing but the angle between the respective normals to the planes. So this is pi 1, this is pi 2, then this is n1 vector, this is n2 vector. So how to prove this? As this much angle is theta. Now see that this normal vector to this plane, so this much angle is 90 degree and this much angle is theta. So how the measure of this angle is 90 degree minus theta. Now as this one is 90 degree minus theta, now see this n2 vector, this vector is also perpendicular to this plane. Now this much angle is 90 degree minus theta and this much angle is 90 degree. So what is the measurement of this angle? Obviously theta. How we have got this? Because 90 degree minus 90 minus theta. So we have in our hand simply theta. So we have proved this much angle is theta and this much angle is also theta. So we have come to the conclusion that the angle between these two planes are nothing but the angle between the respective normals of the planes. So that's all for mathematical models. So now we will go to the blackboard. Thank you, Algosto. So now we will get the proof of the whole theory in detail. So without wasting any time, let's go to the blackboard. First we will draw the diagrams as usual. So first we draw a plane called plane pi 1 in green color. So now again I will draw another plane like this in blue color. Name this as pi 2. Now here let the equation of two planes are pi 1 is r vector dot n1 vector equal to d1, and pi 2, equation of plane pi 2 is r vector dot n2 vector equal to d2. So n1 vector and n2 vector are normal to the planes. So at this common point I will draw the normals. This is pi 2, we draw the normal like this as n2 vector, and from this point, this common point, we will draw the normal vector n1 vector to the plane pi 1. So now see, the angle between these two planes is actually theta. Now as this is theta and now this n2 vector is perpendicular to pi 2, so this much angle is 90 minus theta, as we have understood by the models. So now this much angle is 90 minus theta, but now n1 vector is perpendicular to pi 1, so this much angle is 90 degrees. So now this much angle, so becomes what? 90 degree minus 90 minus theta equal to actually theta. So we have understood in the diagram also, the angle between the two planes, that is theta in this green color, is nothing but the angle between the respective normals to the planes here in white color. So now if undo theta be the angle between the respective normals n1 vector and n2 vector to the plane, then cos theta equal to what? Then green color, cos theta equal to, we know, n1 vector dot n2 vector by n1 vector magnitude into n2 vector magnitude, and take whole magnitude to make the, so n1 vector dot n2 vector by this. So this is the vector form. So this is vector form. Now we are going to understand the Cartesian form also. Before that we will see a particular note. So if, what is the note? If the planes are perpendicular to each other, then n1 vector is perpendicular to n2 vector, therefore angle between them theta equal to 90 degree, therefore we know from the concept of dot product that n1 vector dot n2 vector equal to 0. Now if this is note 1, now note 2, if the planes are parallel to each other, then what will happen? If the planes are parallel to each other like this, then the respective normals to the planes like this, they are also parallel to each other. So we can say if the planes are parallel to each other, therefore the normals to the planes n1 vector must be parallel to n2 vector. Now we are going to understand the Cartesian form. Okay. Now let the equation of the planes be a1x plus b1y plus c1z plus d1 equal to 0. This is plane pi 1. This is the Cartesian equation of the plane in normal form, and pi 2 a2x plus b2y plus c2z plus d2 equal to 0. So here a1 b1 c1 and a2 b2 c2 are what? Are the direction ratios of the normals to the respective planes. So therefore direction, in short I am writing that direction ratios, D ratios. You should write direction ratios in full. So direction ratios of normals, respective normals. Direction ratios of respective normals to the planes are A1, B1, C1 and A2, V2, C2. So cos theta equal to what? We have got n1 vector n2 vector by n1 vector magnitude n2 vector magnitude. From this easily we can write that a1 a2 plus b1 b2 plus c1 c2 by root a1 square plus b1 square plus c1 square root a2 square plus b2 square plus c2 square whole magnitude. So this is relation 2 is the Cartesian form. So according to the problem which we were asked in the examination, we have to use the forms vector form or Cartesian form wisely. Okay. So now again we are going to find two notes. If the two planes are perpendicular to each other, then theta equal to 90 degree, then cos theta equal to what? 0. So here see previous page, cos 90 equal to 0. Then if we put here cos 90 equal to 0, then from this relation we can easily tell a1 a2 plus b1 b2 plus c1 c2 equal to 0. So a1 a2 plus b1, this is not 1, b1 b2 plus c1 c2 equal to 0. These things we have already discussed in angle between two lines. This is same thing, because angle between two planes is nothing but the angle between the respective normals to the planes. And normals are what? Normals are nothing but those lines in the space. So here all the results and notes are same as the theory what we have discussed in our early lectures, angle between two planes. So please go through the previous lectures also, then you can understand this very easily. So a1 a2 plus b1 b2 plus c1 c2 equal to 0. So this one note 1 and note 2. If the planes are parallel to each other, then in that previous lecture we have derived a form in the form we have found the angle theta in terms of sin theta. From this sin theta, as the angle these planes are parallel, so the normals to the planes are parallel. As the normals are parallel to each other, so angle between them theta is 0, so sin 0 is 0, and that from that relation we can easily understand that a1 by a2 plus b1 by b2 equal to c1 by c2. So this is note 2. So these particular notes will be very useful if you asked in the exams to check whether two planes are parallel or perpendicular to each other. So now we are going to see one beautiful application of this theory what we have learned now. One application of the theory. Okay. Find the angle between the two planes. 2x plus y this and this. So using vector method. So here the equation of the planes are given in Cartesian form, but here in the question they are asking to use the vector method. So from here directly we can write direction ratios of normal to the plane 1. Say this was plane 1 and say this one plane 2. Plane 1 n1 vector equal to here 2, 1, minus 2. Also direction ratios of normal to the plane to n2 vector. Here I am writing simply the components only. You should write like that: 2 I cap plus j cap minus 2 k cap. Here n2 vector direction ratios are 3 minus 6 minus 2. From the question I have directly written this. So now cos theta equal to what? n1 vector dot n2 vector by n1 vector magnitude into n2 vector magnitude. So now n1 vector dot n2 vector. So here we just apply the dot product. 2 into 3, 6, minus 6 into 1, minus 6, and minus minus plus 4 by root n1 vector magnitude. n1 vector is what? This one. So magnitude is 4 plus 1 plus 4. And n2 vector magnitude is 3 square 9 plus 36 minus 2 whole square means 4. Take the whole magnitude. So equal to 16 minus 6, 10, so 14, and here 4, 4, 8, 9, so 3 into here 36, 4, 40, 49, 7. So equal to 14 by 21. Therefore, theta equal to cos inverse 14 by 21. So answer. So we are done. So now next page. So here I have given you one problem as home assignment. So if you are a serious student, my humble request to you, please solve this problem and put the answer in the comment section below. It will motivate me a lot. So we are at the end of today's lecture. Hope you have enjoyed today's lecture a lot. Thank you for watching.